Now, as I've said before, I will never be the person to say go to the casino and gamble. That's a bad idea, because casinos only exist because people understand the math and they understand how to make it a profitable business, which means they take your money. However, I'm going to teach you as much as I can, so if you decide to play games of chance, board games, strategy games, I'm not talking casino games, I'm talking games of chance, you have an opportunity to win. Alright, so I need side conversations to end because I'm only going to give these rules once. Okay, so I'll wait another like 30 seconds or so. We got some people trailing in, but I'm only going to give the rules for this game once. What you can do while you're waiting for me to give those rules is go ahead and on your paper, create this number line. On your paper, create that number line. And I'm going to do the same thing. So today is 524 probability tables. So I'll write it up here. So head your notes. Right, Layla? One through 12 on your number line. Now, you have 10 chips to wager. You walk up to the simplest game in the casino. I don't ever seen National Lampoon's Family Vacation, Vegas Vacation, I feel like, where they lose all their money and then the son wins the 4 cars. So at one point, Clark Griswold, love Clark Griswold, has lost all of their money except for like $17 or something. And they're like, all right, we're going to win this money back. We're going to go play the easiest game in the casino. And I think he walks up to a table and it's like high-low. It's like a game of high-low. Like you guess, you flip a card and you guess is the next card going to be higher than that or lower than that. And I think he continues to lose their money. Today we're going to play as simple of a game as I can devise dealing with dice. But here's the rules. You are going to place your 10 chips wherever you want on this game board. What you just created on your paper is a game board. So if you made your number line way up high, you're going to place your chips below your number line, but I don't really care. So you have 10 chips to place. If I want to put a bet on a 1, I'm going to put a circle above my 1. That's a chip of mine. If I want to put a bet on an 11, I put a circle of that. If I want to put 3 bets on 9, I'll put 3 circles above that. So this is going to be the result of rolling 2 dice. So make your bets right now. Place your 10 circles above or below the numbers that you want to bet will come up. You want that number to be rolled. Okay, place your bets now. Shh. You're playing. So the first person to win all 10, you can't win multiples at a time. The first person to win all 10 gets a piece of candy. So here's the deal. If a 9 comes up, I don't win all 3 of those. I win 1 of them. I would need 3 9s to happen to win all 3 of those bets. Until somebody wins.
You're rolling 2 dice, right?
2 dice.
Wait, how many chips do we have?
You have 10. You have 10 bets to place. Where did my blue... Okay, I'm missing a little blue bowl type thing. Aha. There are thumbtacks still in it. That would be why. I used it for thumbtacks earlier on. Now, without giving away your bets, who thinks they had a better chance than just guessing. And without giving away your bets, who can talk about why they think they have a better chance than just randomly guessing? So don't tell us what you guessed. But you, no? Yeah? No? No? Alex? That still seems like guessing. What game? Of course. My favorite game, well, that, yeah, I can still probably say that. My favorite game in the world, Settlers of Catan. Now, people will call this a gateway game, like kind of like as a joke of like, you know, gateway drugs or things like that. They get you deep down into things. So that's a joke of once you can think of as drugs. So as soon as you play Catan, this is why they call it a gateway game. You'll want to play it more, and you'll want to play other games. Right? It's a gateway to more games. So then you start playing like Sky Realms or like all these different games. So, but one of the things about that game, Catan, and we've played this, is all the numbers randomize on the board every time, but they have these little dots beneath them. Those dots are very peculiar. Everyone's got their bets made, right? Yes. If a 9 comes up, so I don't have all my bets made, but if a 9 were to come up, what I'm going to do is put a check mark that I won that bet. If a 6 comes up and I don't have any 6s, I just don't do anything. Okay? Now, if you want, this might help you kind of learn something from this. Keep track of the results. So somewhere else on your paper, I'd maybe draw a squiggly, and just keep track of the results. If the first roll is a 3, write down a 3. Next roll is an 8, write down an 8. Like, you can just keep track of the results. It will help you make sense of what we're doing. You ready? You just spread all your bets out?
Yes, it's the easiest way.
All right.
Not very good at it.
Moment of truth. Ready? Roll 1. Oh, this is way too bright.
What's 7?
7. Wow, it's bright over here. I need something to like block it. Hey, Mr. Smith, would you do me a favor and keep track of these on the chalkboard or something? You can erase the map info. All right, we got a 7. Next roll. If you had a 7, cross one out or put a check. Next roll. 8. Sorry, it's kind of hard to see. Next roll. We got to go fast because we don't have much class time. 4. Next roll. 6. Has anyone won every single one so far? Ooh. All right, next roll. 10. I wonder, I can't get rid of that glare. Next roll. Rogue die. 9. Next roll. 7. Next roll. 4. Double snake eyes. I'm not doing anything.
You are doing something.
Snake eyes.
Use your magical teacher powers to make a 6.
Is there anyone with only 1 bet left to win? You only have 1 bet left to win, Sky?
Bet.
Our settlers of Catan. What? Wait, how many bets have you won?
I have won all of them except 1.
Oh my gosh. Our settlers of Catan representative over there seems to be doing better than anybody else. Next roll. Next roll. 8. Sky, what are you waiting for? Look, there's no way to control dice. There really is not. Unless they're weighted. 6. Ooh, for a second I thought you got your 5. 2 bets left. 8. Sorry, 8.
Yes!
Are you done? One more? Ooh, it's down to it. No, wait. Jose, what do you need? You need a 9, and you need a 5. Now I want, hold on. I wonder if there would be a way to predict whether Jose is going to win sooner or whether Sky is going to win sooner.
What numbers do you have?
And by the end of the class, you'll know. 5! That's it. Is that all your bets? Sky wins. Now, who only had 1 bet left? Raise your hand. Who only had 2 bets left? 3 bets? 4 bets? More than 4? Like you just don't even want to say how many? Okay. All right. So draw squiggly. We're moving on.
We're gonna do it again.
So let's say Jose's upset, right? Which I would be upset if I had 1 bet left. Sky, see me after class, of course. I would be upset if I had 1 bet left. So Jose, guys, I've entertained the idea of doing this more often because I thought if we could be in the family room and just have all Math 7 kids together, we could mix up groups and everything else. But please, like, right now you're showing me this is a challenge for me. I keep having to shush and everything else. Like, we got 20 minutes left. A little bit more, actually. You could have time to work on your homework today. Like, probably you should, but if I have to keep wasting time to quiet us down, it's not going to work. So Jose gets upset, and he wants to look at all of the results of the dice rolls. So he says, all right, I know that and I could go ahead and relabel these as my red die and my green die, right? So I have those 2 dice over there, 2 different. You can see them. I could have matchy-matchy, right? All of them match. Or 1 and a 2, 2 and a 3, 3 and a 4, 4 and a 5, 5 and a 6, 1 and a 3, 2 and a 4, 3 and a 5, 4. And quickly Jose gets bored. He's like, this is a lot of work to do. So he's thinking there has to be a better way to show the outcomes of rolling 2 dice. Anyone have an idea of a better way we could organize this? How many outcomes are there possible on the green die?
6.
How many outcomes possible are there on the red die? So technically, when I roll 2 dice, how many outcomes are possible? 36. So for Jose to get all of the outcomes, he's going to need 36 rows. Or to set this up differently. So what we do to set this up differently is set up what we call a probability table. So if you could please write down probability table.
What'd you roll?
8.
Wow. Wait, do we need to keep the number line?
I mean, don't erase it. Yeah, I mean, just keep going down your notes. We're going to say probability table for 2 events. A probability table is perfect when we have 2 events happening. Now, if there are more than 2 events, we probably wouldn't use a probability table, but we don't need to get into that today. The reason we use a probability table is to organize the results. You okay? So we're going to set up a table, but what we're going to do is have my red die, and what are the outcomes of red? Possible? 1, 2, 3, 4, 5, or 6. And then my green die, I could get a 1, a 2, a 3, a 4, a 5, or a 6. And then, if you did not make this nice with your graph paper, draw some grid lines. Why are you being mean to me? The computer. Hey, Mr. Hall. You came in at the perfect time to see me failing with my smartboard. I failed.
Well, failing is just another word for growing.
So, Mr. Hall, I don't know if you play Catan, but our Catan player in the room just won our dice rolling wagering. And I think Catan gave her a huge advantage. I'll play Catan. We have our tables made. Doesn't need to be fancy. Red die, green die. Now, when we laid out, come back to me. When we laid out our bets, Labiba had an interesting strategy that I like for, like, you know, let's spread things out. She just put one bet on almost every single place. But there were a couple that she didn't put a bet on. Labiba, what didn't you bet on? A 1 and a 2. Why didn't you bet on 1? You can't get a 1. Why didn't you bet on 2? It's not very likely. Because the only way to get a 2 is what? 2, 1, snake eyes, right? So our 2 in our table lives right here and only there. That's the only 2 that we can get.
Whoa.
What if I roll a red 2 and a green 1? I get a 3. What if I roll a red 1 and a green 2? Ah.
I'm writing this down.
So which is more likely? 2s or 3s? 3s are more likely. Fill in the rest of your table. What goes inside is the results. Fill in the rest of that table. Well, I can't remember if it's the actual first problem. Yeah, your homework problems are related to this. Yeah.
Hey, just to keep on going on.
Look, there's a pattern. We're really good. You know what happens if you doing the next 100?
Oh, buddy. So we should have this filled in. No. Your actions right now. What you're showing me. I don't know. All right, now I heard somebody saying there's a pattern. Who was that? What's our pattern? What's our pattern? A wusha?
Yeah.
I don't know what that means.
Yeah, no, it's a feeling.
Give me math terms. Math terms.
2 and then 3
Oh, so it's diagonal. So what we're saying is those go diagonal. These go diagonal. These go diagonal because it fixes it sometimes. These go diagonal. So wait, what does our table here actually then show me? If we go back to our bets, and I give you one bet, what would you bet on and why? Since Sky, since you won, I want to hear from you.
Kevin has is the most opportunity to get, and that was this is just random, but this was the first number that we rolled with 7.
Right. Those rolls actually match probability pretty well. We could go back and analyze all the rolls that we made, but when we look at probability, I dislike my smartboard. Please, beneath this table, write P of red. Yeah, or beside. When we talk about probabilities, random cards is kind of hard today since we're two groups merged. Scythe, when we talk about probabilities, what goes on the denominator? Probabilities are out of 1. Right? If it was percent, we'd have 100 on bottom. It's been a couple weeks, right? Because we had winter break. Not here, actually. I know what you're thinking of with that 6. Kevin? Why? I got a lot of people not listening, and Kevin's dropping good knowledge on us. In the denominator, I'm afraid a lot of us would have struggled to answer that because we took a couple weeks off. The denominator is your total possible outcomes. When I look at the entire table, how many total outcomes did we say there are? 36. So our denominator here needs to be 36. That's the total amount. Even though there's only 11 different numbers, because we don't use 1. There's only 11 different numbers, but there's 36 different rolls with red die, green die. How many of those are red? 6. Can this reduce? It is 1 out of 6 if we reduce it. And this, and I love encouraging you guys to play board games. This is why. Now, technically, I shouldn't have even let Sky play. Technically, Sky had an extreme advantage because she already knows everything I'm teaching you today. What's the probability? What's the probability? And write this on your paper. What's the probability of getting a 9? In this table, what's the probability of getting a 9? Write it on your paper. What's the probability of getting an 11? Or an 8? Or a 6? Or a 2? Sky cheated, if we're being technical. She knew all these probabilities before we started. Ah, my lights are way too bright. Check it out. What was your probability of 9? 4 out of 36. What was your probability of 11? 2 out of 36. What's your probability of 8? 5 out of 36. Probability of 2? 1 out of 36. So guys, that game, favorite game in the world, has been designed, I'm trying to block some of this light, to show you the probability. Now, based off everything we just said, what number is the most likely? 7. That's why, in this game, they removed the 7. There are no 7 tiles. Instead, you know what it does? What do you mean 6 what?
6 also has the same probability.
As 8? Yeah. If I pull out a 6, it has the same probability as 8. Because look at the table. They're on like opposite sides. So,
Oh yeah, I forgot.
6 has the same probability as 8.
I don't think it's 7.
Here, we'll clarify this for a second. Give me your eyes. I don't need you writing anything right now. Just give me your eyes.
I'm not sure to take them out.
Crud, I got off. I used... Yeah, it happens occasionally. Do we see how that probability is mirrored? Because there's only one way to get a 2 and one way to get a 12. 2 ways to get 11, 2 ways to get 3. So, because 7 is so much more likely, the game decided...
To make it where you can move the thief.
Yeah, depending on which version of the game you get, they either call him the thief or the robber. This guy lives on the board, and when a 7 gets rolled, it activates, he jumps up and moves, and then robs from somebody else, or just blocks a property. So so the game said 7 is too probable. It's not fair, because nothing equals 7. 7 is the most probable. Nothing equals it, right? 6 and 8 are equal, their probability. 5 and 9 are equal, their probabilities, but nothing equals 7. So guys, if you had one bet, one chip left to try to win, you should put it on a 7. If it's rolling 2 dice. Does that make sense? If it's 1 die, that's a great question. If it's 1, I don't know where my giant die went. If it's 1 die, are there different probabilities? But, if I'm rolling 1, Ava, what's the probability of a 1? We're not looking at this now, but I can tell that you're not paying attention to me. Joey?
1.
Out of?
1 out of 6.
What's the probability of 2? Grace? No! How many 2s are on 1 die? What's the probability of 3, Maria? What's the probability of 4? Guys, when you roll 1 die, there's no advantage or disadvantage. Every number has an even probability. All right, we got to move on. We're on 59 now. We're skipping. I know, we're skipping. You have a bag. Again, we're making super easy casino games. You have a bag. Red block, green block, blue block, yellow block. You plan to make 2 draws from the bag, replacing the block after each draw. This is bringing us back around to some vocab we talked about before we went to winter break, and I bet we forgot. It's like, Layla, if I ask you what the difference between independent and dependent is, do we remember? Exactly. So especially you guys out in the wings, like far away from me, I need you with me right now. So we have a bag. Right? There's a red, a yellow, a green, and a blue. I mean, you can if you want me to. Go ahead and draw the bag.
Yeah, it's all back.
What on draw 1 is the probability of getting a red?
1
1 out of 4.
25%.
Now hold up. If I keep that block out, right? I'm changing the situation for a moment. If I keep that block out and then I move on to draw 2, and I ask, what's the probability of blue? Don't write this down, please. And I say, what's the probability I get a blue? If red's gone, 1/3. Right now, hold on. Should my probability of blue be different than red?
No.
Not if this is fair, quote unquote fair, right? That's a dangerous word. But when we talk about independent and dependent events, a dependent event, so somewhere off to the bottom or side, dependent
Oh, I remember.
means chances change after something happens.
That's also a bias.
Not necessarily. Yeah, I see your connection, but not quite. Dylan, you got this right now? Don't lie to me. Just say no. I would draw on my hand. I need to write this down now. So, independent means the opposite. If I pull my red out on draw 1 and put it back in, then what's my probability of blue on draw 2? 1/4. It should be the same as it was at the beginning. And I'm afraid you're going to fall backwards. So, independent means nothing changes. Independent events, chances don't change. A dependent event means something changed because something happened. Right? I pulled out a red, I kept it out, that changes things. But in this situation, it says we put them back, which means it's independent. Questions? Remember, when we talked about this back in December, I described it as like you depend on your parents determine what you do and kind of the choices you make. Like, I'm independent, I'm not changing based off, I'm just doing my own thing. Independent does not change, dependent did change. So if you want to make an example of a dependent probability here, just to have it on your notes, you could say, if red gets kept out, then the probability of blue is 1/3. So if you want to write down that example, if red got kept out of the bag, blue now changes its probability, which is not good. Unless that's what we want. So, if we ask, what's the probability, I'm looking at B now, what's the probability of getting a red block and a blue block? Now, we're going to go back to their original game, so I'm going to redraw my bag. We're going to pick one, put it back, pick the second. Right? Pick one, put it back, pick the second. Red, yellow, green, blue. Oh, you don't have to draw it again necessarily. I want you to talk with your team. What's the probability of getting a red and a blue, but you need to make a probability table to defend.
What's the probability?
So, draw 1 and draw 2. So set up that probability table. If we're putting, guys, I have so many side conversations it makes me want to retire. I'm just laying it out there. There are times when it's like, you guys just don't give a crap. It's better to put on a YouTube video to teach you math, and you can just have a robot teacher, and it's fine. I'll just go do something else. I'll go take my job as a park director or something like that. I've got other things in my head. What else could I do with my life? Please quit making me think about retiring. I don't like that. Well, I want 7th graders to listen. I changed my degree field from elementary to middle school so that I didn't deal with 4th and 5th grade behaviors. What can happen on draw 1? What events, Aiden? Well, what are the events that could, what could you get? I agree, there are 4 things that can happen. Red or yellow or blue or green, right? Red or yellow or blue or green. If I put the block back, what can happen on draw 2? A red, a yellow, a blue, or a green. Fill in your probability table and then determine what the probability is. I would write draw 1 first, because otherwise you'll confuse yourself. Yellow, red, blue, red, green. I filled in my first row, but I also filled in all of my draw 1s. If draw 1 gets a red, it's red, 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 like all of draw 1s are red. But then I could have a draw 2 of red, or a draw 2 of yellow, or a draw 2 of, you can come grab the stuff if you want. And I could have a draw 2 of green. Again, Mr. Fraze, you guys know him. Go Club today. Nice shirt. If draw 1 is yellow, fill in your draw 2s. Fill in your draw 2s. Fill in your draw 2s here if you haven't yet. Any volunteers, we'll do that because it's probably the last question of class. Any volunteers to tell me the probability that you get a red and a blue, but order doesn't matter?
What? 1/8.
Is that reduced or is that? It's reduced. So give me the unreduced. 2/16. So we're looking for red, blue. So you got this, and you got this. So how many total outcomes? 16 actually. How many have red and blue? Only 2 of them. Right? I mean, we got blue, blue, we got red, but that's not what I just want blue, red. There's no others. So the probability of red, blue, sorry, I don't need prob, I just need P of, if we want to be technical. P of red / blue is 2/16 or 1/8. I know that some of us don't have that written down because you didn't know it before I wrote it. Once you have that in your notes, you are good to go. Now, hold up. You are a minute or 2 early. So if you cause a ruckus outside of Pettigrew's classroom, it will come back on me. And you better believe I'm not going to release my 3B class early again. Or 1A for that matter. So do not be loud in the hallway. Like, sneak past Pettigrew's room. Do not go in there either. They're still having class. Do not go in the other side of the pod. Yes. Ghost ninjas, right? You gotta be a ghost ninja.
Or PlayStation main reference.